Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we're going to explore quantum theory as it relates to parapsychology. With me is theoretical and experimental and quantum physicist Dr. Ed May. Perhaps more on the experimental than the theoretical side. Ed has been the Director of Research for the U.S. government's military and intelligence psychic espionage program known as Project Stargate. That he directed for over 10 years and was part of for another decade before that. In addition, he is the recipient of a Lifetime Career Award from the Parapsychology Association. He is the co-author of ESP Wars, East and West. He is also the co-author of Anomalous Cognition, Remote Viewing, Research and Theory, and he is the co-editor of a 2-volume set of academic papers called Extrasensory Perception, Extrasensory Perception, Support, Skepticism, and Science. Welcome, Ed, and thank you for the prompt.
You're welcome, Jeffrey. It's my pleasure.
And it's a pleasure to be with you once again.
Okay.
Now, you're very experienced as a physicist, knowledgeable about nuclear physics, quantum physics, parapsychology research, and many of the theoretical developments in which people have attempted to explain parapsychological phenomenon in terms of quantum physics.
Yes. Let me give a little background history of myself here. For 10 years, from 1964 all the way up to about 1974, I was a workaday experimental physicist in nuclear physics. You cannot understand what it is you're looking at until you invoke quantum theory. Mm-hmm. Now, that said, am I a good quantum theorist? Not on your life. Mm-hmm. But to say that nobody understands quantum theory, like the often quoted from Professor Feynman, if you find someone who tells you they understand quantum theory, you can assume they're lying. That's not really true. Mm-hmm. Why is it not true? We all have cell phones, smartphones in our pocket. If someone didn't understand quantum theory, we'd never have that. That said, there are some deep, deep, deep mysteries, which it is true that nobody yet understands, wave-particle duality and so on. But let's get down to the nubs here. First of all, is everything quantum mechanical? The short answer is yes. Mm-hmm. Why? Because atoms make up everything we know about.
Yeah.
You're made of atoms. I'm made of atoms. That chair is made of atoms. So the laws that govern these micro things bouncing around are indeed quantum mechanical. But that's not the part that gets really interesting. Mm-hmm. The fact is there are other aspects of quantum theory just in how the atoms move and what have you. There's some pretty interesting things going on there. Yeah. And one of them that seems to be very popular in the popular literature these days is entanglement. Mm-hmm. Everybody's talking about entanglement, and at one time I saw an author that said everything's entangled. Well, no, it's not. And people even talking about psychological entanglement. Entanglement, the language of physics and the language of quantum mechanics seeps into the popular discourse.
And it's always been the case that leading edge of science seeps into the popular discourse. Right. And in the 17th century, animal magnetism was the hot topic.
Right. Well, you put a glass of water in your microwave and you nuke it. No, you don't nuke it. But that's one example.
Yeah.
So, that's great. I think those, scientists shouldn't be put on a pedestal and only use their jargon and that's great. I have no objection to that. Mm-hmm. Can I tell a brief story about that?
Yeah.
There is an idea in quantum theory called quantum leap. Go from here to here at a big jump.
The quantum leap.
Leap, yeah. In fact, there was a TV series of the same name. Mm-hmm. I'm walking out of the Pentagon one day with a colonel, and he said, "Ed, we've got a new nickname for your program. It's called Quantum Leap." And he was really excited. And I said, oh, do we have to? He said, what's wrong? He said, well, a quantum leap progress report is the smallest possible progress I could have above none. That's a crummy name for our project.
Well, I grew up understanding that a quantum leap meant that an electron would go from one orbit to another orbit without ever passing through the space in between.
Exactly. That's the real definition of it, but it's seeped into the jargon of everyday discourse, meaning a massive discontinuous jump no matter how big it is.
Yeah.
And that's okay. I don't have any problem
Sure.
with
And it's a mystery. How does the electron do that?
Right. So if a bowling ball has a whole bunch of atoms in it, therefore is a quantum device, how come I say it's a classical system, it's not a quantum system? What makes me say that, where an electron really is a quantum system? Well, a famous physicist of the early 20th century named Debroglie was able to see that sometimes particles are chunks of matter, and sometimes they act like waves. And that's a big mystery that no one actually has the answer to. So Feynman's right about that. But he's able, given a chunk, he can say, well, what's this wavelength? How far between the ups and hills in the wave? And it is that wave property that allows electrons to behave like waves going through two slits, and you get double slits just like light does.
Right.
Okay, so why doesn't a bowling ball do that? If you have a big slit that round, you start throwing bowling balls at it, they never show a diffraction pattern. They never show wave properties at all. Why? The de Broglie wavelength of a bowling ball, if you could actually compute it, is smaller than the atoms in the surface of the bowling ball. So that's one of the things that differentiates a quantum system from a classical system.
Okay. In other words, there is a quantum wave function for a macro object.
Sure, of course.
It's just so tiny as to be irrelevant in the macro world.
Precisely. Now, how about a brain? There's a lot of thought, a lot of discussion out of parapsychology, and there are even journals about it. Quantum psychology, quantum ESP. I have a real problem with that because what is the de Broglie wavelength of a brain? It's not much different than the de Broglie wavelength of a bowling ball. Your wave function, if you could compute it for your entire brain, does not extend out through your scalp. So if you want to say, well, I'm going to affect that thing over there, my quantum connection between my brain and it, I'm sorry, it's not going to do that because your wave function for your brain doesn't extend over there.
But the wave function for the particles within my brain might be different.
Well, that sounds very good. So let's look at, people have looked at that in some detail. A physicist by the name of Tegmark said, let's examine that exact question. Here we have a neuron, and let's suppose there's an adjacent neuron, and they're entangled, they're related quantum mechanically. How long do they live? Turns out MDQ, mighty damn quick. They don't live very long at all. And the reason for that is an interesting concept called environmental decoherence. The best way to illustrate that to you, there are contests, there are people compete who can make the largest chunk act like a single quantum thing. So bowling ball isn't even in the competition, brains aren't even in the competition. The current record as of last year, maybe 2 years ago, 500,000 rubidium ions. Wow, that's a speck so small you need an electron microscope to see it.
500,000
rubidium. Rubidium, yeah, it's one of the elements. And that's neat. The whole thing is acting like a large quantum thing, but at a billionth of a degree above absolute zero. Now, I know a lot of cold people around me, but their brains are not just above absolute zero. If you raise the temperature enough, environmental decoherence bangs into it and ruins the entanglement.
Well, isn't it fair to say that the application of quantum theory to the human brain is such a relatively new field that it's likely that in the coming decades or even coming centuries, we're going to learn a lot more about it that we don't presently know?
I disagree.
Okay.
Because there's a mystification of quantum mechanics. And except for that one area of wave particle wave duality, which nobody understands. The rest of it is extremely well understood.
Okay.
In other words, the brain, there are quantum processes in a single neuron. We have single ion calcium channels and single ion sodium channels. And yes, they open up and one ion goes through. It's really behaving like a quantum mechanical system. And in fact, there's entanglement within a given neuron. And some people speculate that's the origin of alpha rhythms in the brain. No problem. The next neuron over here doesn't have any idea what this one is doing. They're not entangled.
Now, I have interviewed Stuart Hameroff, who is one of the major theorists looking at consciousness and quantum mechanics, and he talks about the microtubules
I'm glad he does.
Inside the neurons, which are much, much smaller structures.
Yeah, microtubules are almost kind of like the superstructure that keeps the neuron from collapsing on itself. And they're filled with water.
Yeah.
At a temperature of 37 degrees Celsius, 98.6 Fahrenheit, their body temperature. And I've talked to Stuart directly about this. I said, tell me why, if that's quantum mechanical inside the microtubule, what prevents what is called environmental decoherence from ruining it? He has no answer for it.
Okay.
And nor has any of the publications.
So what you are suggesting is that people who are attempting to explain normal human consciousness in terms of quantum theory haven't gotten very far and are not likely to.
I think, well, I'll be mean and be nasty. I think they're dead in the water before they start.
Okay.
And part of it is, and I really don't mean it as harshly as I said it, there really is a reason we would like to try to do that because of what I said before. The metaphors of quantum theory are fantastic.
And we have all this data from parapsychology that suggests something akin to a quantum leap.
Yeah. It's a bit of a political statement when George W. Bush used the word nuclear instead of nuclear, as one made my skin crawl. When people tell me that psychology and personalities are based on quantum theory, my skin crawls equivalently. Because where I get upset about it, frankly, I guess I do, is I'm prepared to invite anything brand new. But please read the last 80 years of research of a lot of people doing a lot of theory and a lot of experimentation that directly contradict what you'd like to be true. That doesn't mean you're wrong and they're right. It means you've got to do better homework to say, well, they were right, but they're missing a point, and here's the thing they missed. To my knowledge, no one has done that yet.
Well, I suppose it's useful to distinguish between the use of the language of quantum physics as a metaphor for what's going on in human consciousness as opposed to mechanism.
That's right. I have no problem with that. In fact, it can be very insightful. So this business of decoherence, nature has done a nice thing for us. The military wants to build a weapon based on quantum mechanics called a carbon dioxide laser. It emits a huge beam of infrared light, and they want to be able to burn holes in tanks at a distance with it. So it all works. And the way that works is you have a big tube and a lot of carbon dioxide gas in it, and you run an electric current through it, and a bunch of the carbon dioxide molecules get really excited, and they are entangled. And so this one goes blurp and spits out a photon, and it travels across the tube, hits this other one, and it de-excites and puts out more photons. That's called a kind of cascade effect, and that's what gives you the laser light coming out the end. Now, there's a problem. I mean, the military wants to scale that up to make a huge weapon out of it. Well, nature prevents them from doing that. Here's the problem. Here's one carbon dioxide molecule, here's another one, and they're entangled. Now, they're banging into stuff. There are a lot of high-pressure other gas in there. If the time it takes the photon to go from here to here is shorter than the time average time between collisions, something will bang into this one before the photon reaches it, and that's called decoherence, quantum decoherence. It will not laze; it stops lasing, which is great. That means they can't build weapons out of these things.
Okay, now how is that related to consciousness?
Not at all whatsoever, as far as I know.
But your point is?
The point is quantum decoherence prevents quantum mechanics are being related to brain experience of consciousness.
Okay, so the same problem with this laser weapon is the problem that prevents quantum coherence in the brain from being an explanation of consciousness.
Yeah, as I said, Tegmark computed what the lifetime of entangled adjacent neurons are.
Yeah.
Well, I'll say it in jargon, it's 10 to the minus 17th. That means decimal point with 17 zeros and a 1. Mm-hmm. That's mighty quick.
Too fast for the phenomenon that we know are associated with human consciousness.
Yeah, and why that happens so quickly? Because we have a warm, soupy thing called a brain. Mm-hmm. And as I said, the all-time current record only happens at a few billionths of a degree above absolute zero, and the brain isn't anywhere near that.
Well, you seem to be suggesting, therefore, and I believe you are from our conversations, that we will be able to understand the phenomenon of human consciousness as well as parapsychological phenomenon in terms of conventional notions of brain function without resorting to quantum physics.
Well, as you know, in the sort of debate about consciousness, I'll tell you what the extremes are. One are the dualists, like Sir John Eccles, very smart fellow, and he said, if you think consciousness, if you think consciousness resides in the brain, say he, then you don't know your neural anatomy. Yeah. That's the ultimate dualist perspective.
And Wilder Penfield, another great neurophysiologist, was a dualist.
Yes. The other end of that scale are there are many people, but the doctors Churchland at UC San Diego.
Yes.
They hold that consciousness is an emergent property of the neurons and their interconnections.
Yes.
Now that sounds really weird, but physics is full of emergent properties. One we were talking about in one of the previous discussions we've had, namely time going in one direction is an emergent property of a lot of little electrons or a lot of little particles moving around. That's another way to think about it.
Yeah.
So the question then becomes, as neuroscience evolves, is there new data that points toward dualism, or does all the new data currently point toward physicalism? Mm-hmm. And the answer, so far what I've seen, it all points in that direction.
Now, and the idea of an emergent phenomenon, it's sometimes called epiphenomenalism, is also materialism or physicalism.
Of course, yeah. Now, my own sort of wishful thinking, I hope I'm wrong. It's much more interesting on the other side. I'll give you a little story. I was a guest of honor at the Ramakrishna Mission Institute of Culture in Kolkata, the resident materialist, and I had a lengthy conversation with a Ramakrishna Mission order monk.
Yes.
And he was saying, well, my point was, these ancients in India and other cultures were brilliant. They were able to come up with self-consistent philosophies that based on almost no data.
Yeah.
And so I said, Swamiji, my goodness, if what you are proposing is correct, non-material consciousness and all of that, and I hope you're right, then it must be consistent with the new stuff we know about. We now know about brains, we know about genetics, we know about physics and all that. And he says, you're absolutely right. So he and I are still in dialogue trying to tough our way through all of this.
Well, the philosophical problems are probably a lot harder to deal with than the scientific problems.
Very much so, and that's why I try to steer free from... Well, can I tell you a brief anecdote that was very funny?
Yeah.
I was visiting a colleague at Eötvös-Loránd University in Hungary, in Budapest, and the head of the philosophy department from Princeton was there. So my friend invited me up to hear what he had to say. I listened to an hour of theoretical philosophy in English, and I did not understand one word he was saying. And I'm thinking, those poor Hungarians were English as their second language. Turns out the only person in the room that did not have the clear understanding of what he was talking about was me. So I told my colleague, if you ever do that to me again, I'm never coming
Well,
here.
I think partially that's because philosophers now have such specialized language. It's hard for a non-philosopher to understand them, just as it would be for a non-physicist to understand a physics conference presentation.
Well, it turns out we have a contribution in that 2-volume set we spoke of by a philosopher from San Jose State University. He has used our data as part of the evidence why he should become a full professor. And I've gone down to talk to his class. He loves this kind of work. He's very fascinated by it.
And his point is?
That parapsychology will inform philosophical discussions for the future.
I would hope so.
Me too.
Yeah. But what you're saying is that while ever since J.B. Rhine, in fact, to be honest, ever since the founding of the Society for Psychical Research in 1882, the effort has been to use the data of parapsychology to support a dualist position. I think that probably most parapsychologists are in that direction, and you're arguing that it need not be that way.
That's true. I'm one of the minority there. More than a minority of one. There are a number of people that agree with me.
Yeah.
Well, I think the serious take-home message here is nobody really knows the answer to this. And so if you're going to propose some nifty new idea, an application of quantum theory, please be my guest and do it with my blessings. But at least acknowledge what you're about to propose. It does not fit easily into what's been done for the last 80 years. And what upsets me, frankly, is all these people, and to a minor degree I was one of them, that worked tirelessly, and not because of any philosophical viewpoint, they're just trying to understand nature, acknowledge that and say, well, hey, they were pretty good, but they overlooked this little piece and we're moving forward. Fantastic.
Well, I think it's fair to say that at this point in time, there must be, I'm going to say dozens, and it might be hundreds for all I know, of books and papers out on the market by serious thinkers. They're not all theoretical physicists, but they are all very well-educated people who are trying to relate quantum physics to consciousness.
Yeah, and it's attempting a seductive metaphor to do just that. I find it attractive. And it helps me to try to organize my thinking. The only difference is when you move something from metaphor to fact, you have to have your quantum ducks in a row.
And you were an experimentalist primarily, and you really know the experimental data of parapsychology. You've looked very carefully at the experimental data of neurophysiology. Well,
what you flashed a memory in my own mind here. Where the language of quantum theory gets misplaced. Very common in parapsychology, we hear the term non-local.
Yes.
In quantum mechanics, non-local has a very clean definition, certainly in nuclear physics.
Yes.
And basically, out of the four forces that we know about, gravity, electromagnetic, two types of nuclear, one of them is an actually non-local force. And that is strong nuclear. And if you don't put in the equations of how non-locality works for a strong nuclear force, you can't fit your data of experimental nuclear physics.
Okay. And now, technically speaking, if I understand it, non-local refers to outside of what's called the light cone.
No.
All right.
Now,
good. I'm glad you've corrected me.
Well, only within the contents of nuclear physics.
All right.
Generally in physics, it says a force on a little tiny particle represents a mathematical thing called the change of potential around it. And you evaluate that potential at one point. That's called a local force.
Okay.
A non-local one is a force on a test particle must be evaluated in a little non-local area, it's a tiny one, around that spot.
All right.
And it's about the width of an atom. It isn't very big.
I see. So that's a very precise definition.
In nuclear physics.
Okay.
Now
that's different than the definition I was giving you about the light cone.
Where that came was in the Einstein-Podolsky-Rosen experiment, where you distant things, and they say J.S. Bell said, no local force can account for it.
Yeah.
He was right, but he also missed it when he said it is also true that no non-local force can account for it, because there's no force involved in those experiments at all.
It's an information transfer.
There's no transfer of anything. Newton, let me give you a quick lesson of Newton. Newton said things that in motion stay in motion until you bang into one.
Yes.
Things at rest stay at rest unless you push on it. What he didn't say, but it's equivalent, things once correlated stay correlated until you bang into one of them.
Okay.
Because that's what we meant. That's what technically means in quantum decoherence. All right,
So quantum entanglement, in that sense, is the correlation of things that were correlated to begin with.
Right, and there's nothing that says they can go halfway across Europe unless they bang into something, they're still correlated. And you can flip your polarizers all you want, because these things do not have any, that's another mystery of quantum mechanics, that particles do not have any properties at all until they're measured. And in those experiments, they're only measured at distance. So it's no mystery at all. I mean, most people don't think the EPR stuff is a mystery at all.
Well, Einstein, as I understand it, referred to it as spooky action.
And you know what? Completely wrong.
And
everybody who talks about spooky action, it is not an action.
Spooky action at a distance.
And the reason for it is, let's take a polarization where light bounces up and down, and you put Polaroid glasses to prevent that from seeing it. You're in glare. And let's assume that photons are in fact polarized inherently. And it's absolutely true. If you change your polarizers when the particles are outside where they can communicate, there's got to be a spooky action at a distance to take this one to what it would have been to some other position. All right, but that's a wrong idea entirely, because these things do not have polarization. They are not required to change from one state of polarization to another. They just maintain the correlation.
I see.
That's really, and that's why you can't send information. You cannot flip your polarizers and send SOS. There's nothing you can do with that.
So what you're saying is that the people who maintain that non-locality or entanglement are related somehow to, let us say, telepathy, they're on the wrong track.
I think so. Now, that said, there are some very smart people that disagree with that. One is Henry Stapp, a good friend of mine. And he's got a whole different model altogether. And there are true. The opinion space of physicists on this topic are overwhelming in one direction, what I feel. There are a handful that agree with Henry. That doesn't mean they're wrong. There have been lots of examples in science where the mainstream was completely wrong, and maybe they're wrong here. Right now, the data doesn't suggest they are.
Well, I'm happy to give you an opportunity to present an alternative point of view.
Thank you.
Because, after all, we can all learn from the debate.
I hope so.
Ed May, this has been very enlightening, and I appreciate the opportunity to hear you out and to give others an opportunity as well to appreciate there's more to materialism than we might normally appreciate.
Well, thank you. I hope that people understand that this is one point of view with a lot of people who agree with it, but it doesn't necessarily a priori mean it's correct.
It seems to me that the strength is in the debate itself.
Indeed, I agree.
Ed, thank you for being with me.
My pleasure as always, Jeffrey.
And thank you for being with us.